All right. Thank you so much for moderating and that introduction. Thank you to everyone for sticking with me and also on those evaluations. I really appreciate it a lot. So now we're going to talk about the soil. We're going to get in there deep. I want to focus on fertility here today. So I won't be talking a lot about microbes and all the things, but we'll focus on fertility for a little bit. So those of you who are just coming in, I'm originally from Wisconsin. All my degrees are from the University of Wisconsin. So I grew up on eastern soils, and then I moved out west to Utah, where the soils are quite different. But there's actually a lot of similarities across when we're thinking about small farms and flower farms. So today's topics, I'm actually going to start with an example, and then I want to throw in a little appreciation for the soil, thinking about it as a bank for nutrients, and then how to soil test and why, selecting amendments and calculating rates. So to get started, thinking about soil, one of the things that I've noticed, and it's actually been really well documented in the literature, is that our urban farms, our small farms, can be really high in nutrients. There's this tendency, I would say, to kind of love it to death, right? If there's a farm that's got thousands of acres, there's only so much you can spread, right? Land serves as a control. And this first came to my attention during my PhD. So my PhD research was on dairy manure management in the winter to reduce nutrient losses, and we were looking at till versus no-till systems. So today I'm going to try to cover all the types of farming because there's reasons to do things. I'm not trying to take a side on one or another. So we'll talk about till versus no-till. We'll talk about conventional versus organic options. That's up to you. So I was working with large-scale CAFOs. Soil nutrient management was a big deal. And then I was running a community garden on the side, and I started soil sampling, and I was shocked. I thought we were being very good stewards to our environment. We were adding compost every year. But boy, the soil test came out higher than a lot of the CAFOs I was working with. And it was a really big wake-up call. And since then, there's been a lot of research on it. My team's conducted it in Utah. There's a lot going on across the U.S. So I want to show you an example. And one thing I want to preface right away is that wherever you are, and if you decide to do a soil test, highly recommend it at least once. Make sure that you send the sample into a lab in your state, because it depends on the region you're in. We've developed soil tests over time so that they're most fitting toward the soils of the area. So the tests that we do in Utah are really different than what's done out east. So that said, I'm going to show you numbers. I know that they're kind of irrelevant, but I just want to use them as reference. So in Utah, or anywhere, part of a routine soil test is to look at how much phosphorus and potassium are in the soil. And I've got what our recommended rates are, soil test values. So for soil test P, 21 to 30, soil test K, 126 to 300. Meaningless number, but it's there for reference. So we've been doing surveys. I've been trying to go to as many urban farms as possible. This includes vegetable farms, not just cut flowers. And just for reference, so this is where we want to be, the average is around 4 times higher than what we want for soil test phosphorus. This is an environmental pollutant when it gets high. And for soil test potassium, we're sitting kind of pretty. It's a problem in Utah if there's too much potassium. It actually adds to the soil salinity, which we have to worry about. So that's urban farms in general. And then if I look at flower farms in particular, they're higher yet. Okay, really, really high. And so this is what I want to talk about, because there's really no benefit once the nutrients get so high. And second, it's just an extra input cost that we can cut right away to help the bottom line. So even though these test numbers are different than what you'll see, it's the same story everywhere. I haven't surveyed flower farms here in Kentucky, true. But I know that a lot of the small farms, this is a new area of research. So that's what we're going to focus on today. So let's take a bit to get excited about the soil. The soil does a ton of things for us. I think we all have this wonderful appreciation, but I just wanted to list a few things that it does. It serves as a filter. It holds water. It's an amazing bank, not just for nutrients, but for water. It's got this structure. So there was a speaker from the USDA who gave a talk, and she was thinking about being a good steward of the land and the things that we should consider with the soil. And so, of course, soil productivity, number one, right? We have to be able to produce a crop in the first place. Second is thinking about the environment. And third, conserving the soil. It takes on average 1,000 years to develop 1 inch of soil. So really trying to conserve it. And where all these things come together is this area that is soil health. And soil health can be interpreted in a lot of ways. Today we're going to think about it in terms of having sustainable nutrient management plans. So I get really excited about soil. If at any point I'm going too fast or you have a question, you just shout out. Raise your hand, don't raise your hand. Probably better to shout out and stop me. All right, so I said it's a tremendous bank. The soil actually has a lot of bank accounts. It's got a checking account, it's got a savings account, and it's kind of got something like a custodial account too. And so it is amazing because plants actually need 14 mineral nutrients. If one of those nutrients is deficient, the yield potential can't be reached. So it doesn't matter if I throw on all these other nutrients that it already has enough of. If that one is missing or inadequate, we will see a drop in yield. There's actually 17 total nutrients if we count hydrogen, oxygen, and carbon. So CO2, H2O, water. But these are the mineral nutrients. And we really want to be in this optimum level. There's been decades of research to figure out what those are. Full disclosure, cut flowers are kind of a new crop though, and so there's been work that's starting on that, but we have a pretty good idea from the other research on other crops that's been done. So the reason to not get above optimum is because there's no benefit to production. It's not going to increase yield, and then it also can be an environmental hazard. So when there's too much phosphorus and it gets into our lakes and rivers, that's what causes algal blooms. If there's too much nitrogen, it can leach into groundwater, blue baby syndrome. There's the hypoxia that happens in the Gulf and so forth. So to be a good steward, it is of my opinion that we really need to be in that optimum level. Okay, so this is a list of the mineral nutrients. Don't have to write this down. They're divided into two categories. Macro means large. It's what the plants need the most of. Micro means they don't need as large a qualities, but again, they need all of these to be at their full potential. And I've done sort of a color code here. The ones that are in bold are the ones to keep a bit more of an eye on, and the ones that are here in brown to gray are less of an issue. So the good news is that with this tremendous bank that we're managing, most of the nutrients are kind of set. There's just a few that we really have to pay attention to. Fun story about sulfur. This was never a deficiency, and part of the Clean Air Act that cleaned up coal power plants actually has reduced the amount of sulfur deposition, and so we are starting to see some sulfur deficiencies, especially in really heavy areas for production. But so that's coming on the radar. Keep it in mind in the next 10 years or so. But the real big ones I highlighted here are nitrogen, phosphorus, and potassium. So those are our three primary macronutrients. I also highlighted zinc because here in your soils, if phosphorus gets really high, it can actually lock up the zinc and make it unavailable to plants. And so these are the ones to kind of keep more of a close eye on. All right, so the importance of soil testing. I do like numbers and that's part of it, but really the soil is a black box. It's hard to look at it and know what it might be lacking or needing. And you could wait for the plant to show a visual deficiency. We can read those symptoms relatively well, but a lot of the symptoms look the same. And often if you wait until the visual deficiency shows up, it's too late to correct. There's going to be an effect on yield. So it's nice to check in ahead of time, know what the soil needs, and add to it. I'm not going to talk a ton on texture, but this is really important for water and nutrient management. Something like a sandy soil, it's not going to be able to hold as well. Things are going to leach through more quickly. So adding nutrients in several applications instead of one big one is a good idea, whereas clay type soils are going to hang on more. It also has a kind of effects on liming decisions too. I saw that UK has a phenomenal resource program when it comes to soil testing, that your county extension office is very, very helpful with helping you get those soil samples off to the lab. So that was awesome to see, and there's a lot of really great handouts. I'm not here to pretend like I know your soils better than you. Of course, the county knows its county soils, and you have that intuition that you've built up over years to know your property better than anybody else. So Soil sampling plans. I just want to talk about some overall things to keep in mind. One of the topics that comes up a lot in large scale ag or big ag is that this idea of drones and flying over and figuring out these nutrient management plans are really in depth. And the good news is that small farms, we can do that too. We don't need fancy drones to do it because we have such a close look at our farms. I recommend trying to zone it into 3 areas. Maybe that's too much and you just want to look at one zone. But the idea is that if I were to look at my entire farm and soil sample randomly across it, I would get the average. But maybe there's a spot that's not doing well, or maybe I'm treating another area really differently. I wouldn't want the average of that. And so these are some ideas in the list to think about when you're making a zone on your property. All right, so the recommendations are to sample every few years to check in. I guess my standards have gotten low just once. Try to get a baseline. That's really, really eye-opening. I think I have a picture. Yeah, I'll save my story for a couple slides in. One free resource I want to quick point out, we don't have a ton of time to go into it, is that the federal government back in the day did a soil survey across the US. One of the things they were looking for is prime agricultural land. And so that information is available on the NRCS website, which can be kind of slow and cumbersome. And then UC Davis came along and they made it a bit more user-friendly. So the website is there. I also just Google UC Davis soil web and it comes up. And this is all free. Let's see here. A few things though is that back in the day, they absolutely did not take a soil sample and then step right here and take another. They did not do that. They sampled every few acres. They looked at the landscape features. And so the boundaries between different soil types, it's kind of hand wavy. So if you live near a boundary, I highly recommend taking a look at what's drawn right next door. But if you go to this site and you put your address in, it'll draw these yellow lines. And these are the delineations where they're estimating different soil types exist. And then you can click on it and there's all kinds of information. You can look at what the soil would look like if you dug a hole, how deep the topsoil is, and so forth. So it's a fun one to take a look at. But anyway, back to zoning. I have this little example. Welcome to Utah. This is where I live. I have 0.37 acres. And so I want to talk about how I decided to zone. So there's kind of this part of a historic orchard left in my front yard that I've since made into more of an orchard. I've got perennial flowers. I had vegetables. There's a lot more vegetables now. Shrubs. This is right next to my house. My house was built in 1918. It's made of wood siding, which means I need to think about lead paint and contamination in the soil. And so these are just examples of maybe what would be a different zone. My vegetables I treat as annuals. These perennial flowers, I treat them very differently. Maybe if you have well water in one area and water from your house on another, just some ideas. And then I have a buddy who has this pasture in back. And so I definitely wouldn't mix animals in with crops because there's that different input. So think about what makes sense for you in your farm. Maybe you do it by bed, or maybe you've been treating several beds the same way and they can be grouped into one zone. Endless possibilities. So whenever you do develop a zone though, make sure you take more than one subsample. I like to carry a 5-gallon bucket around with me and I take samples every so often. And the reason for that is if you just take one sample, you never know what happened there. Maybe a dog came and peed and it's gonna be really different than the rest of the area. There's all these different guides that talk about how to randomly sample. And I just wanted to show a few of them to show that they're all kind of the same. Just try to get across the area. Except for Wisconsin that has a W shape. Okay. So when you sample, UK recommends going down to 6 to 8 inches for a tilled soil and around 3 to 4 inches under no tillage. Fantastic recommendation, and the reason is that under no tillage, the nutrients can get stratified near the surface. They get kind of stuck there. So it's a good place to check in. So take a few subsamples, combine them in a bucket, mix. Letting them air dry is nice, don't have to. Most labs need around 2 cups. Sometimes they'll have those really cute bags that you can fill. Make sure the bag is full. If you're requesting more tests, you're gonna need more soil. So just check with your local extension office. So shovels work great for soil samples. We also have these fancy soil cores. Here's me in Wisconsin. The soil was so dense. We had to use a hammer to get it in. But these cores are great because they take a lot less volume, and so it's easier to get closer to perennials. So a lot of places they'll lend those out. They'll let you check those out if you would like. All right, so following soil test recommendations. This is so useful. So selecting fertilizers and amendments based on soil report recommendations. There's a lot of research that has gone into this, and I think it can be easy. Boy, I go down the aisle in the store, and there's so many options for fertilizer. And some companies spend a ton of money on marketing. Gorgeous bags. I just want to take it and put it right in. But it's important to know what's in those bags so that we get the right amounts put down. So nitrogen is needed every year. Nitrogen is one of those primary macronutrients. It's one plants need the most, and it's the nutrient that doesn't want to stay in place, right? It wants to go up in the air. It wants to leach lower into the ground below the root zone. It wants to run off. It doesn't want to just stay in the root zone. Whereas some of the other nutrients may stick around a little bit better. They still like to travel, but they'll stick around a little bit better. And we have more science that links, all right, this is the soil test level. This is what you need for optimum production. What I've been finding, whether it's in Wisconsin or it's in Utah or wherever else that I'm advising, is that oftentimes in these situations where people have been adding a lot on, especially where there's been animals, there's been compost, oftentimes you just need nitrogen. But that depends on the soil test, okay? What the soil test says just might not be needed every year. Once those levels get excessive, it's good to let them come down. So when only nitrogen is needed, so say we're in that situation, it's important to select fertilizers that only have N and then use the other things more sparingly. So one of our recommendations has been to use compost and manure based on the P need, the phosphorus need, and then supplement the rest of the nitrogen. If I put on enough to meet my nitrogen need, I've way overdone it on the other nutrients. There's one unfortunate thing with organic fertilizers is many of them come as balanced, so equal parts NPK, and oftentimes if you just need the nitrogen, that's a challenge, although there are some really great options in that case. So I know this is terribly dense and hard to see, but there is this amazing resource from the University of Maryland Extension, and they have this fact sheet. I put the website here, and this is it kind of summarized, and it's talking about cut flower crops in terms of their nitrogen demand. So low, medium, and high. And my general take home from this is that oftentimes perennials are on the lower end for nitrogen need. And also if you're looking at cut flower types and it's not always this, but generally, if it says drought tolerant or low water user, oftentimes it's also pretty conservative with its nutrient needs. And so this can be a really helpful tool for thinking about even knowing where to plant a given cut flower. Maybe you want to put all the heavy users in one bed, so it's one application or two applications and easy to meet those needs. So I thought that was kind of helpful. Dahlia is the one cut flower that we've officially tested for its nitrogen demand, and we found that it's got a really high demand. I have not personally tested the others. We've just estimated them in our trials so far. Okay, so sources of nutrients, there's a lot of them. Just walk down the aisle. We talked a little bit about balanced or all-purpose, where there are these equal parts. But make sure you do that soil test. See if you need everything is kind of the bottom line here. So inorganic fertilizers or conventional types, they often have a higher nutrient content, so you need less of it compared to some organic options. So one thing I want to make another point on is some of these products and reading the back. So there's the numbers on the front, the three numbers, which are always in the same order, NPK, but if you turn it around, there's a lot of other words. So fish emulsion is one of my favorites. It's 511, ammoniacal nitrogen, water-soluble nitrogen, water-insoluble. And so what that means is that if it's available or soluble, nutrients are available right away. Otherwise, it means that they're not available right away. So I want to put a few more examples. So for example, feather meal 1200, I also like this one, but it's 12% water insoluble nitrogen. That means that none of that nitrogen is immediately available. It has to break down first for the plants to get it. So if I were thinking about what my fertilizer options were, I was organic, I would put this down, but I would count on it later in the season. I need something that's available right away for the plants to get started. So that's how I wanted to make the point there. So thinking about that nutrient release timing, it usually takes a few weeks for some of these organic options, so not so long, with the exception of green sand, that can sometimes not in our lifetime break down to something useful. Compost and manure actually break down slowly, and so when we're using them, we want to credit them the next year. I have to kind of breeze through this quickly, but I just wanted to say what you can kind of expect from compost and manure in terms of its nutrient availability. But I'm giving it jazz hands here because this is all just kind of general rule of thumb, but nothing in stone. So a little more on nutrient release timing and thinking about different options. And these are some of the more organic options. Blood meal is another good one for nitrogen only. So being the manure person that I am, first thing I did when I got to Utah State, the soil test lab gave me all their records, all their availability. And I went through and I was really curious about, and Utah's not special with how animals are managed or anything like that, but I was just really curious, manure by livestock type, what can we come to expect in terms of NPK? Nitrogen, phosphorus, potassium, what's the pH? For Utah, they need to know the salinity because we have a lot of problems with that. So I went through all their records. I don't know, I think it was just 10 years of data that were online. And then I published this fact sheet that's available. I made the same table for compost based on what it was made out of. And so I just wanted to point out that this is a kind of helpful tool if you're thinking about what to add. Something like any of the poultry manures are going to be really high and they have a potential to burn your crops unless they're composted first. I was looking for the ideal manure, and I had master gardeners who were asking about deer actually, and we found that deer and rabbit was really great. I looked for what manure has the higher nitrogen compared to the other two, phosphorus and potassium, and kind of a neutral pH. Here you can have a high pH and that's no problem. And there's enough rain to wash out the salt. But I just wanted to show that quickly as a fun source that they're not all equal. Some considerations on organic fertilizer options. Thinking about that nitrogen content, how much N is in there, but then also what is the phosphorus and potassium situation. If there's a lot of phosphorus and potassium, I would use a different source of organic matter. I'd use cover crops, I'd use plant material, things like that to increase the organic matter without adding to the P and K. Salt content, some are hotter than others. Weed seeds, that can be an issue with certain animals and uncomposted sources. But the really great thing about this, I don't mean to be negative, is that it does add organic matter, which we can always use, especially when we take land and put it into production. That's really intense on it. And so it's important to replenish that organic matter back and try to also increase it. So I did this old school thing and I included this. So if you ever wanted to calculate by hand how much you need, but I saw that the UK actually has a really helpful fact sheet where you can put in your soil test results and what it recommends, and it calculates it for you. But for anyone who's interested, if the soil test tells you you need however many pounds of a nutrient and you have a bag of something, this is how to calculate how many pounds to add. So if it says you need 2 pounds of nitrogen per 1,000 square feet, say you're a conventional farmer and you're using urea, so 4600, the first number is the nitrogen, you just divide it by 100. So it's in a decimal form and it's 2 divided by 0.46, and you need about 4 pounds to add to 1,000 square feet. If your bed is smaller, then you would add less of that. I also have this organic example of feather meal or blood meal. They're around the same, and so if it's a 1200, you'd need 17 pounds to hit that because it's just less concentrated. 12% of that bag is nitrogen in this case, and 46% of the bag is nitrogen in the other case. Okay, so that's how much to add. We also have a fact sheet on calculating it for small areas. This is the same across the US, and we just have this handy dandy worksheet to kind of spell it out. And then if the bed is a different size than what the soil test says or is recommending for, you can tailor it for your need. So with that, that was really, really fast. But I wanted to summarize and say that the soil is a nutrient bank. And so with the soil fertility do's and don'ts, do replace the primary macronutrients or certainly any nutrient that's needed with the routine soil test, you'll find out where these are at. And so soil testing, I really can't stress it enough that it's so helpful to get a baseline. When I moved into my house, the previous owners were not outdoors people. And so I know nothing had been added in a really long time, since at least 2 owners ago, which was, I guess, 15 years before that. I did a soil test and I was shocked at how high it was already. Phosphorus was already excessive, potassium was, and so just check in once, and it's just so telling. If you can do it more, check in a couple years, that's really great, but it just at least once. Do read the back of the fertilizer or amendment label. Don't over apply. So knowing really what it has, more than the artwork, it's what is it in there and is it available right away? You're going to need nitrogen about every year. Phosphorus, not always. So definitely check that out. And I guess a little caution on woody material, that it can tie up nitrogen. So with that, you guys made it. I'm finally done. Thank you so much for everything. If you could fill out that survey, that'd be phenomenal. And then I have 4 minutes for questions.